When you hear the word chemistry, you probably picture a lab, right? Bubbling beakers, maybe some complicated formulas on a whiteboard. But what if I told you that chemistry is actually the secret architect of your everyday life? That it's happening all around you, right at this very moment? Okay, so let's dive right in. Section 1, chemistry in your day. And believe me, it's a lot closer than you think. So I want to kick things off with a question for you. Just think about it for a second. What in the world could possibly connect frying an egg, scrubbing a greasy pan, and an old nail, slowly turning that reddish-brown color? I mean, they seem totally unrelated, don't they? Well, the answer is the absolute core of our explainer today. They are all chemical reactions. The very fabric of our daily lives, from the mundane to the amazing, is woven together by these fundamental transformations. Just think about it. Striking a match, that's a super fast combustion reaction. Cooking dinner tonight, you're basically a chef and a chemist, causing all sorts of changes in proteins and sugars. Burning firewood, that's rapid oxidation. A rusting nail, that's just slow oxidation. Even those leaves rotting in the yard, that's decomposition, a super complex chemical breakdown. It's all chemistry, just happening at different speeds. And it's not just about things happening around us. It's also about the stuff we deliberately make. The whole reason soap and detergents work is because of how their molecules are designed to grab onto both oil and water. Perfumes? Just a bunch of carefully engineered compounds designed to smell good. And plastics? Well, they're these massive, long-chain molecules called polymers, built from the ground up to be strong, flexible, or whatever we need them to be. Okay, that brings us to Section 2, the science of matter. So, with all these examples flying around, you might be asking, what is chemistry, really? What's the big idea that ties all this together? At its heart, chemistry is the science of, well, stuff, matter. It's all about answering a few key questions. First, what is something made of? That's its composition. Second, what's it like? Its color, its density, its texture, those are its properties. And maybe most importantly, how does it change and why? Those are the rules, the principles that govern everything from an explosion to a quiet rust. Now, if you zoom out a bit, you'll see chemistry is one of the three main pillars of pure science. You've got physics, which deals with the big forces and energy. You've got biology, which is all about the incredible complexity of life. And right in the middle, you have chemistry. It's kind of the bridge, the science of the stuff that physics acts on and that biology is built from. All right, Section 3, a recipe for discovery. So we know what it is, but how do scientists actually figure all this stuff out? It's not magic, right? There's a process, a kind of recipe for learning about our world. And you know what? It all starts with a simple human quality. It doesn't begin with some crazy equation. It starts with someone just looking at the world, noticing something interesting, and asking that one simple, powerful question, why does that happen? And that little question why is what kicks off the scientific method. First, you see something. That's your observation. Then you come up with a possible, reasonable explanation. That's your hypothesis. Next, and this is the important part, you have to test it with experiments. And if your idea holds up again and again, and other scientists test it and get the same results, then it can eventually become a scientific theory. But here's a really important question, something that gets to the absolute core of how science actually works. What if your experiment fails? What if the results totally contradict your brilliant idea? Is that it? Game over? No way, not even close. In fact, this is where the real magic happens. This is the self-correcting engine of science. A negative result isn't a failure, it's a huge piece of information. It tells you, nope, that path is a dead end. So it forces you to go back, rethink, and create a new, better hypothesis. It's how we get closer and closer to the truth. Which brings us to our final section, our chemical world. Because this whole process, this recipe for discovery, isn't just for textbooks. It's the very thing that has taken us from basic survival to the modern world we live in today. Just look at how our relationship with materials has changed. For thousands of years, humanity was basically just experimenting to survive, trying to find better food, warmer clothes, stronger shelters. It was all about basic needs. But fast forward to today, and modern chemistry is totally proactive. We don't just find materials anymore, we invent them. We design and create completely new things. Plastics, medicines, super strong alloys, to solve problems our ancestors couldn't even dream of. And that's really the big takeaway here. Studying chemistry is so much more than memorizing the periodic table. It's about understanding the fundamental rules of everything, the matter that makes up you, me, this planet, the entire universe. It's like learning to read the instruction manual for reality itself. You know, from the very first human who figured out how to control fire, all the way to the scientists creating brand new materials in labs today, our story has been about one thing: taking the matter around us and shaping it into something new. The building blocks are still the same. The world is made of matter. The only real question is, what will we make of it next?